Okay, let's just start by making some true statements. So this component is just delta y because it is the height or the difference between this point in y and this point in y. So delta y, the formula for it is 1/2 a, and since we're focusing in the y direction, it's just ay times t squared plus vi in the y direction times t. Now we know that in the y direction, acceleration when it's in free fall is g times t squared. And we can expand this. So v iy, if we look at this angle of the projectile that we're given, theta, the y component is opposite to theta, and vi is the hypotenuse. So we can solve for viy by expanding it to v sine, because sine is equal to opposite over hypotenuse of theta times t. Since we're also going to be solving for this x value, it is important that we note that delta x will be equal to 1/2 of a in the x direction times t squared plus vix t. Again, we know that without a motor in the x direction, a acceleration is always equal to 0. So we can just cancel this whole first part out, this first term. And then using this hypothetical triangle again, vix is just equal to v cosine theta, because the x component right here would just be the adjacent. And cosine is adjacent over hypotenuse. Using v, we can do v times cosine theta to solve for the x component times t. Delta x, or x, is just equal to v cosine theta t. Now we're going to move on to the other triangle. Delta y, let's make some more true statements about that. Using this angle given right here, alpha, delta y is opposite to that angle, x is adjacent to that angle, and t is the hypotenuse of this triangle. So we can solve for delta y by stating that x tangent of alpha, because tangent is equal to opposite over adjacent. And if we multiply the x over, we can isolate for delta y. Now that we've made these two true statements, we can set them as equal to each other. Now, you can see that there's still t's in this equation, and we don't really want that. So we can use this to isolate for t. So we isolate by dividing it over, dividing v cosine over, because this right here, this will just cancel out. So we can substitute for t into this equation. What we can do now is distribute this square and multiply it with these terms outside of the parentheses. So we're just combining now, we're just simplifying. G of x squared, because we're distributing this square, over 2 times v squared cosine squared. Oh. And then plus. Now you can see here that there's an x in every single term. So we can actually just cancel those out by dividing the entire thing by x. So g of that just becomes x now, over 2v squared cosine squared of theta plus v sine of theta v cosine theta equals tangent alpha. Now you'll see from here that these v's, they actually cancel each other out because v over v equals 1. So we can just get rid of it. you see this function here, it's a trig function. If sine of an angle over cosine of the same angle, we can simplify it to just tangent of that angle. So we can change this to our goal, right, is to isolate for x. So you can do that first by we're subtracting over this tangent to the other side. So, and then we have to get rid of this denominator. So we multiply that over to both sides so that these can cancel. So we're left with gx equals to 2b squared cosine squared of theta times tangent alpha minus tangent theta. And finally, we can divide the whole thing by g to solve for x. And that should match your answer. Okay, now that we've proven that this equation is correct and we want to solve for x, we can just plug in the appropriate values using this equation. X equals 2 times v, which is 50 squared, times cosine squared of theta, which is 60, times tangent of alpha, which is 30, minus tangent of theta, which is 60, all over negative 9.8, because g equals negative 9.8. And then when you put this into your calculator, you will get that x is equal to 147.283 meters. So this is the horizontal range. Okay, so in part C, it gives us a D equation to prove. So let's look at the triangle. Now this is the D that we're trying to solve for. So let's just focus on this triangle here, the incline that they give us. Now they give us this angle alpha, and this side, y, is opposite to alpha. This D is the hypotenuse of the right triangle, and x is adjacent to alpha. Let's just focus on D, the hypotenuse, because that's what we are trying to solve for, and x, the adjacent side to alpha, because from part A, we already solved for what x is equal to right here. So we can start by making true statements. Cosine of alpha is equal to adjacent over hypotenuse, or x over d. We want to isolate for d, so what we can do here is bring this d up by multiplying and bring this cosine down by dividing over. So we're basically just switching their spots to isolate for d. And since we solved for x down here, we can plug this formula into this x. And then we have this cosine of alpha down here, so multiplied by cosine of alpha on the bottom. Now you can see tangent of alpha here and tangent of theta, if you remember the identity, the trig identity, that tangent of an angle is just equal to sine of that angle over cosine of that same angle. So we're going to convert these tangents into sine over cosine of their respective angles. So what we're going to do here is actually combine these two fractions by using like terms. So what we can do is multiply this by cosine theta over cosine theta, because cosine theta over cosine theta is just equal to 1. So we're not changing the value, but we are making it so that we can combine these like terms into one fraction. This side, we're going to multiply by cosine of alpha, cosine of alpha. And now we can just simplify. And what you notice here is you can actually just cancel this cosine theta with this cosine theta. So we can make this just a singular cosine theta and then cancel this denominator out. Let's rewrite it. Okay, so now that we've simplified the cosines of theta, we can actually take out this negative in the g, because remember that g equals negative 9.8 technically, but since d is a positive, we want to just take out this negative. So we can take it out from the top and just apply it here. Because these are all multiplying with each other, we can just attach it to this term. So let's rewrite it. Instead of writing the negative out here in the front, we're going to do it inside the parentheses. So negative cosine theta sine alpha plus sine of theta cosine alpha over cosine alpha. Instead of negative 9.8, it will just be 9.8. My next step now is to focus on just this numerator inside the parentheses because it's looking really familiar. Do you remember this function? This trig identity sine A times cosine B, A and B both being different angles, minus sine B times cosine A equals to sine of A minus B. Well, in this case, since the negative is on the sine of B cosine A, the negative is here. Sine is attached to alpha here, and sine is attached to B here. So B is alpha, A is theta. So we can go ahead and just plug that in. This part matches with this part, and this part matches with this part. So we can just replace this whole numerator with what we just proved right there. So let's rewrite it. And our last step here is to just bring this cosine alpha to the bottom. Let's just rewrite that to make it more simple. So this is our final equation for D. Okay, so we're asked to find D max, and we already proved that this equation for D is true. So we can use it to find D max. Let's start off by simplifying this angle by creating a new variable, C equals to theta minus alpha. So D equals sine of C. There's two trig identities going on here that can be recognized and changed. The first one being cosine of some angle times sine of another angle is equal to 1/2 of sine of that first angle plus that second angle minus sine that first angle minus the second angle. And in this case, x correlates to the angle theta and y correlates to the angle z. So we can just replace this statement into our equation in numerator. Let's also get this identity out of the way. Cosine squared of some angle. I'm just going to use alpha because that's what that angle is. And plus sine squared of that same angle will equal to 1. And since we have just cosine squared, we can isolate for it by subtracting over sine. So 1 minus sine squared of alpha. So we can replace this into our denominator there. So let's just make those substitutions. So we see that there's a 2 on the top and bottom of the numerator, so we can just cancel those. And since we're looking for the maximum value of d, we want the numerator to be the largest possible value it can be. So for this portion of the parentheses, we want that to be the largest it can be, and that is only possible if this value that is being subtracted from is the largest possible value it can be. And the largest possible value of sine is 1. So we're just going to replace that with 1. So 1 minus, and then we're going to leave the second one as is over d 1 minus sine. Now, do you remember that angle C is equal to theta minus alpha? Well, here we have theta minus c. So if we subtract c over and add alpha over, we realize that this angle is really just alpha. So we can just go ahead and replace that. So we can expand this into 1 plus sine times 1 minus sine. So let's rewrite it. We can start canceling it out. So this is 1 minus sine alpha on the top, 1 minus sine alpha on the bottom. So we're left finally with v squared on top and g times 1 plus sine of alpha on the bottom.